Hello, I'm Mr. Malden, and this is the Middle School Math Toolbox where I teach you how to become a middle school math master. So if you're interested in that, hit the subscribe button down below. Today we are going over geometric figures, all right, things like angles and the like, all right. So we're just going to be spending, a lot of time going through some of the vocabulary here, and then we're going to talk about some different things that you can do with angles, all right, in terms of like sketching them and measuring them as well. So, all right, let's just go ahead and dive right into this. All right, the most basic geometric figure is a point. It's a point in space, all right? A location in space represented by a dot on a sheet of paper. That's how we like to represent them. You can title angles with a capital letter, all right? So often you'll see, not angles, points with a capital letter. Often you'll see, like if you had a coordinate grid just like this and you had a point out in space, all right, and you see like a Z next to it, all right, that's saying point Z right there, all right? All right, the next most basic shape is a line, all right, when it comes to geometry, and just going over these, you're really wanting to focus in on the notation, on what constitutes a line when we're actually drawing it on a sheet of paper. Because when it comes to geometry, we have some limitations when it comes to drawing things on a surface, on a sheet of paper like this to communicate it to each other. So it's really important in this video and in this lesson to really pay attention to the notation. Whenever you're making a line, all right, what makes it a line in the drawing, all right, is this idea that it continues on forever in both directions, all right? A line is a set of infinitely many points. So if I were to take a point and I were to draw points in a, what we know of as a straight line, and I kept drawing them and I kept adding more and more, eventually it would just look like a line, all right? Just like this right here, the one that I drew. All right, so when you have an infinite number of points to the place that you can't even distinguish between one point and the other point, they'll form a line. And when that line continues on forever in both directions, it's a line, all right? The way that we communicate that is just a straight line with arrows at the end. Again, those arrows mean that that line's going forever. Right? We can't draw the complete extent of that line because it never ends, and therefore we can't, put it on a single sheet of paper or something like that. So the way that we have to communicate that is just to simply say this line keeps on going forever in both directions. Okay. A line's can be named by using 2 points that are on the line. All right, that's one way to name it. All right, so you could say this right here was line PQ, and since we had, each of these labeled P and Q, we could just say this is line PQ. Another way we can name it is by using the PQ like this and just putting a line over the top of it like that, all right? That's a very short way to write line PQ, and that's the predominant way that you're going to see it, especially when you get into high school, when you're taking geometry in high school, you'll see that a lot, all right? So, but that's another way to title that line. And then one other way is by simply just adding a lowercase variable to it as well. So like this right here, when I just put that lowercase variable next to it, I'm saying this line, because I don't have a dot next to that M anywhere, what I have next to it is that line. I'm saying that whole line is line M, all right? So those are 3 different ways that you can see a line titled, all right? A line with 2 points being mentioned, all right? And then the same 2 points with the line over the top of them, that's a predominant way that you'll see it. You'll see that a lot. And then this is also a predominant way, all right? Especially when you've got a diagram that has a lot of different lines on them, they're going to title each one of them, just a simple, short little letter so that you can be able to find them pretty easily, all right? All right, a line segment. So if a line continues forever, as indicated by what you see on your screen right here, you see this line with 2 arrows at the end of it. If it continues forever, then a line segment is a straight line between 2 points, but it stops, okay? So the key word here is segment, all right? A segment stops at an individual point. So a segment is just part of a line that contains all the endpoints and all the, that contains the two endpoints, and it contains all the points in between them. So again, if we took, all these little points in between these two dots, we got P here, we have Q, and we have this infinite number of points in between those, then eventually when we add enough of them, it starts to look like a straight line, all right? And that's what that means. That's what that part of the definition means. All right, line segment can be called segment QP or segment. You can, just like with lines, you can use the 2 points to be able to name them. So in this case right here, it's QP or P and Q. All right, so if it's a segment and you don't want to illustrate or you don't want to communicate that it's going on forever, then you'll write segment, all right? And then you can write the 2 letters for the 2 individual points that the line is in between. All right, there we go. You can also simply just write those letters with the line on the top. All right, let's move on. A plane. A plane is, when I've told you that it's kind of hard in geometry to communicate things on a sheet of paper, a plane is a really good example of that. All right. It's a flat surface, all right? So any flat surface that extends in all directions endlessly is a plane, all right? You could think of it kind of like as a sheet of paper, all right? This sheet of paper is not very thick, all right? It's just a flat surface. So you could think of a plane like a sheet of paper, but it's going to continue on forever. So there is no way that we could get a complete plane on a sheet of paper. So the way that we try to communicate that is by using a parallelogram like this. When I draw a parallelogram out like this in geometry, I'm saying that's a plane right there. And I can name that plane by using 3 points that are on the inside of that. So in this case right here, this would be plane PRQ or QRP or RPQ. It doesn't matter the order of those letters when it comes to planes and when it comes to lines. You don't have to worry about the ordering of the letters. You'll have to worry about that, be concerned with that with a figure that's coming up. But with planes, you don't have to worry about that, all right? So you can name a plane by using 3 points in the plane, or you can just use a capital letter in order to title that. So remember, lowercase letters for lines and then capital letters for planes. So this plane right here is just plane W. So that's another kind of shortened way to be able to write that. And when you have a diagram that has a lot of different planes kind of intersecting each other and all that kind of stuff, they're going to title each plane individually with just a capital letter up in one of the corners. All right, so I'll be looking for that. But that's how you name them. All right, let's move on to array. Array is kind of like a line, except that it stops at one end and it goes on forever at the other end. All right. So it's part of a line with a starting point. So it does have a starting point. And then it extends endlessly in one direction. That's array. All right. And a great example of array is the sun. Okay. When you have the light that comes from the sun, the starting place of that line is the sun. And then it shoots out that ray endlessly in one direction. Now, the sun has a lot of rays, obviously, of light, an infinite amount, and so it shoots light out from all sides, from all surfaces, and straight for infinity. All right, it keeps on going. All right, so that's where we probably got the name ray, or where we got the name sun rays. All right, it's a great example of a starting point for a line and then extending in one direction endlessly. Now, when you're writing or you're titling an array, it does matter the order of these letters. You're going to use 2 points, all right? Like in this case right here, you have H and G, all right? But you have to, the first letter has to be the end point, all right? The starting point of that array. Don't pick the side where the line keeps on going forever. Pick the side that has the dot. That's going to be the first letter of the name. So in this case right here, you have Ray HG. You also will see this written like this with an arrow over the top. You don't see that a ton, especially in middle school and high school, but you will see that some. All right. So that line over the top with an arrow, it's saying we have a beginning point of H, and it continues on through G and then forever. All right. So that's another way that you could be able to write that. All right, now we have an angle, which is just a combination of two rays. So if you have a starting point and you have a line that goes forever in one direction, that's a ray. Then if you take that same starting point and you put another line that's going continuously in another direction, then what you've done by making those two rays start at the same starting point, you've created yourself an angle. It's a geometric figure made up of two rays that share a common endpoint. And you can measure the degree of these rays by using a protractor. And I'm going to show you how to use a protractor towards the end of this video. So if you've come to this video and you don't know how to measure angles, then and that's all you wanted to do, you can kind of skip forward towards the end of the video. And I'm going to teach you how to read an angle, measure an angle, and then also how to sketch an angle. All right? All right, an angle, angles are used to, are named, by using one point on each of the ray and then their common end point. All right, now there is a rhyme or reason to the letters when you're writing an angle. All right, you want to make sure that your common end point is the middle letter. So in this case right here where we have this D and this Z and this F on this angle right here, you can simply write that angle by using the universal sign for angle, or you can spell it out, A-N-G-L-E, all right? And then you're going to use these 3 points to name it. You just have to make sure that your middle letter is their common end point. So you've got D, Z, F, all right? Another possible name for this angle would be angle F-Z-D. But angle ZDF would not be right because that Z has to be in the middle because the Z is their common endpoint, all right? So those are the two variations that you can write for that angle. Angles can also be named, and I don't have this on my PowerPoint slide, but it can also be named by just using a single letter on the outside. Like this right here, you've got F, let's call that was Z, and this one was D, all right? You could call this just angle Z, all right, because that's the vertex. That's the endpoint of both of the rays, so you could call this angle Z. And that's especially true when you've got like a triangle like this, and you've got 3 different letters representing each of the angles. A really short way to refer to that angle would be angle T. All right, just like that. Now, I could have called it angle STR, all right? But that's a really long kind of way. The predominant way you're going to see is by just using that angle. But you do need to understand this because you do see this quite a bit, all right? So if you have 3 letters, it's just telling you this first and the last letter are points on the rays, all right? And then the middle letter is the common endpoint, all right? Let's keep on going. We're hammering through this. All right, collinear points. Collinear points are just points that exist on the same line. All right, so if P, K, and Q, they all are on the same line, so they're considered collinear points. And then coplanar points are points that exist on the same plane. All right, and the way that we communicate that is we put them on the inside of that parallelogram. If I wanted to communicate that there was a point that was not coplanar to P, Q, and R, all right, I would put it on the outside right here, all right? U, in this case right here, U is not on the same plane as P, R, and Q, so therefore these are non-coplanar, all right? If I wanted to illustrate that a point is not on a plane, I'd just simply put it on the outside. Now you may say, well, didn't you say that plane went forever and then eventually it would be, encompassing you as well? You can see from this perspective that might be true, but when you actually when you kind of take a step back, you could be up above the plane or down below the plane. So even though the plane's going to continue to extend underneath it, you could be up above it, all right, or it could be down below. So the way that we kind of just simply illustrate that, if we're going to say that U is not on the same plane as P, R, and Q, we're going to put it outside the plane, just like that. all right? That just goes back to what I was talking about earlier, that we have certain limitations when it comes to geometry, and the limitations have to do with infinity, all right? We can't draw finite or infinite things, all right? So that we just do the best that we can, with the agreed upon method. So with drawing a plane, we draw a parallelogram. If we want to illustrate the points are on that plane, we put them on the inside of that parallelogram. All right, finally we've got intersections, all right? Intersections are points or a set of points where two figures come together that they have in common, all right? If you think about an intersection in life, that's where two streets cross each other. The intersection is actually the actual crossing of them, all right? So in the case of two lines, like you have right here, line PQ and line TB, they both intersect each other at point Y. All right, lines intersect each other at certain points. All right, now sometimes you have intersecting planes, like is illustrated right here with plane W and plane S. They're being intersected, and by nature of two planes being intersected, they're not going to intersect at a single point. They're going to intersect at a string of points all put together. And so two planes intersect each other at a line. So line K is the intersection of those two planes. All right, let's go ahead and let's take some examples here and see if we can kind of just look at this diagram right here and just answer the directive. So what I want you to do in this part of the video is kind of the practice part of the video. You can pause this, you can try it yourself, then you can come back to see if you've got the right answer. So for the first question, we just want to know what are named three collinear points. All right, by collinear we mean on the same line. So pause this, try it yourself, then come back. All right. You see a line right here. There's only one line that's on this diagram. It's the line Y right there. And you've got 3 points that are on that line, Q, S, and T. So the collinear points are Q, S, and T. All right, I want you to go ahead and tell me what's the name of the intersection of ray SP and line Y. All right, so pause the video, try to sort through it yourself, and come back to get the right answer. All right, well, line Y is this big line right here, and ray SP is that line that's starting at S and going through P, all right? And you see that they both intersect at point S, all right? And so that would be the intersection. All right, think about this one. Name the intersection of the planes. Planes B, D, and M. Now notice, so you have the planes. There's an M in the corner over here. There's a D in the corner of that plane, and there's a B over there in the corner of that plane. All right, so we want to know what the intersection is of planes D, M, and B, and so they're all going to cross right here. They look like they're all coming to a point or to a crossing section right here at line Y. All right, those are the planes, and that's their intersection. So the whole line is their intersection. So you just need to get into the habit of understanding that when you've got intersecting planes, they intersect each other on a single line. All right, let's move on to classification of angles, which by the time you get to 7th grade, you should know the classification of these angles. You should have learned these things, but let's just go ahead and review them. Maybe shout out to your screen right now. What's the angle called if it's less than 90 degrees? Or if a measure of an angle is less than 90 degrees, what's the name of that? Hopefully you said acute. All right, and the way that I remember that is a small little angle, so it's a cute little angle. All right, that's not where we get the name acute, but that's how I remember it. All right, small angles smaller than 90 degrees are acute. How about 90-degree angles? What are those called? Yeah, hopefully you said right. All right, that's a right triangle. And then finally, you've got angle measures that are larger than 90 degrees. Those are obtuse. All right, yeah, they're obtuse. All right. Now we've got these 3 angles right here, and I just wanted to go through really quickly and see if you can go through all 3 of them and give me at least one name for each angle. All right. See if you can go back and remember how we named we named the angles. All right. You can either name them by a single letter. You could also name them by the number that's on the inside of that angle, or you can use 3 letters. All right. The middle letter, the the endpoint for both of the rays, and then a point on each of the rays. And just remember, if you're going to do it that way, then the middle letter has to be the common endpoint, right? All right, let's see if you got it right. Hopefully you tried this already. The first one, we've got angle FJP or PJF. We've got angle 70, or I also could call that angle J, all right? I could just call that angle J. For the second one, we got angle SEM or MES. There's 90, or I could also call that angle E. And then the final one is CVT, angle CVT or TVC, or 110, but I could also call that angle V for short, all right? All right, straight angles. We don't really talk about them that much, but you do have the classification of a straight angle. It's just just one angle that adds up to 180 degrees. So, and 180 degrees is the measure of a line. All right, so the angle measure of a line is 180 degrees, and that's why we call this a straight angle, because it's just a straight line. All right, lastly, we're going to talk about measuring angles, and then we're going to talk about sketching angles, and we'll be done. Okay, to measure angles, you need a protractor, and I've got one right here on the screen. All right, the parts of a protractor that are really important, the middle at the bottom, that's very important. This bottom line of the protractor that you see, I'm kind of tracing over with my cursor. That's an important part. And then all the angle measures that are up here. And you notice for each one of them, there's 2 numbers. I'm going to tell you in just a second how to make sure that you're using the right number. All right? So the first thing you need to do with the protractor is line up the protractor where the bottom middle of it is on the vertex, all right, of the angle, or on the common endpoint. The common endpoint for the 2 rays is called a vertex in the middle. So we have lined up the protractor with the middle, with the middle center of the protractor is on the vertex of the angle. That's the first step. Second step is line up the bottom line of the protractor. So you're going to rotate the protractor until the bottom line is parallel or even with one of the lines of the angles. So in this case right here, I put the bottom line on this line right here. And then you're going to simply read where the line crosses the protractor, where the other ray crosses the protractor. And in this case right here, it crosses the protractor in between 190 or in between 80 and 90. Now then, here's how you decide which number is going to be the number that's useful for you. If your angle measure is bigger than 90 degrees, then you're going to use the bigger number. If your angle measure is smaller than 90 degrees, you're going to use the smaller number. All right? Well, 90 degrees is right here on the protractor, and this angle starts on this side, all right, and it goes all the way around past 90 degrees, and it keeps on going. So it is bigger than 90 degrees, so we're concerned we're going to be wanting the bigger number. All right, we either had a choice of 85 or 95. Because this angle is bigger than 90 degrees, we chose the larger angle. It's 95 degrees. All right, now we're going to talk about sketching an angle. All right, we're going to sketch an angle. When you're sketching an angle, you need 3 points. You need a point at the bottom middle, all right, right underneath the protractor, just like that. You need a point at 0, and you could pick either side. It doesn't matter. You could pick this 0, but if you start with this 0, you need to start with the 0 when you're measuring for this next point. All right, if you start on this side, you need to start on the side that says 0. All right, so again, like what I was saying, you needed to, once you put the dot down at the 0, then you're going to make sure you've got 2 different numbers to choose from right here to start with. You're going to start on the side that says 0. And then on that side, you're going to count up until you get your angle measure. So we're looking for 65 degrees. We have our dot in the middle, our dot at 0. Then starting at 0, we're going to count up to 65. There's to 60, and then 5 more. There's my other dot right there. And we're going to place that dot right there. All right. Once we've got the 3 dots put down, then we can remove the protractor, and using the common endpoint, which is the bottom center of the protractor, that dot that you put at the middle, that's the common endpoint. You're going to draw a ray through each line, and you've made an angle, just like that. Okay? All right, why don't you try this one? All right, there's you can try on your own scratch sheet of paper if you've got a protractor. If not, maybe you could hold it up to the screen right here and you could pause it, or you could just wait. You could maybe have one kind of mentally, and then you can compare what you've got in your head maybe to this one right here. So see if you can draw it out though. All right, then we're trying to do 145 degrees for this angle measure. So we need, again, 3 dots. We need one in the bottom center. We need one at 0, and then starting at that 0, we're going to count all the way around until we get to 145. All right, just like that. We got to 140, 145, and then we put the angle measure right, or sorry, the other dot right there. Once we've got our 3 dots, we can remove the protractor and draw lines through each of the rays, and we've got our angle. Now, a way to check it, all right? If it's less than 90 degrees, it's going to be an acute angle. If it's greater than 90 degrees, it's going to be an obtuse angle, all right? Well, this is 145. That's greater than 90 degrees, so we're going to have an obtuse angle. If you drew an angle like this, then chances are you drew the supplement, and we'll talk about that in a future letter. But you drew the other angle that would add to your angle 145 to be 180. But you know, if you've got an angle like this, you've got an acute angle, and if you look at the angle measure, it's obtuse and it doesn't match. So that's a quick way to be able to kind of check yourself, is to make sure that, you know, if you have an angle that's bigger than 90 degrees, then when you go to sketch it, it better look like an angle that's bigger than 90 degrees. And 90 degrees is just straight as a perpendicular angle, all right, just like that. So if it's bigger than that, it's going to be obtuse, and it's going to be bigger than bigger than 90 degrees. All right, that concludes the lesson. If you have any questions whatsoever, you're more than welcome to ask the questions down in the comments down below. If not, I hope you have a great day. We'll talk to you soon. Bye-bye.